Saxon Algebra 2. Well, welcome to lesson 81. We are now 2/3 of the way through this math book. That's very exciting. We're going to go up through we're going to do 120 lessons from this book. If you look at the table of contents, you will see that this book actually has 127 lessons, but we're going to do some editing at the end. I'll tell you more about that when we get toward the end of the year, but we will be doing 120 lessons exactly. Today, we're starting the last third of them, lesson 81, and we're going to talk about complex numbers. We're going to learn to multiply and divide complex numbers, which will be familiar and easy. Don't worry about that. Let me review for you what complex numbers even are. We've talked about them a little, but not a lot. Complex numbers take the form of a plus bi. When you hear the words complex numbers, this is what I want to jump into your head. We always write a complex number sorted into two pieces. The first part is what we call the real number, and that's just a plain number. The second part, the b times I, that's where it gets a little crazy. It gets a little Alice in Wonderland. That's what we call an imaginary number, right? You can't find it on the number line. That's the mathematician's way of saying it is not a part of our reality. So where do imaginary numbers come from? Well, a perfect example is this, square root of minus 4. What's important is that we have an even numbered root, and because this is an invisible 2, right? And a minus sign in here. That's not okay. That does not work out. So what we do is we mentally separate the 4 from the minus 1. We basically take the minus sign and pull it apart, right? So that the minus sign is not attached to the 4 anymore. Now, using the general rule of radicals, I was going to say pig houses, but I'm going to break down and use the actual word. Oh, wait, this isn't what I want to try. That's the next step. We can put these in separate pig houses, right? 4 times minus 1. And then we remember that square root of minus 1 equals I. That's how we get a complex number. So what we do is we separate them, then we turn this into an I. So this becomes, and square root of 4 we know is 2, I. The square root of minus 1, that problematic minus sign, we turn into an I. That's where it comes from. All right? So that would then fit into this arrangement. We also know that if you have a pair of i's being multiplied together, that equals -1. So when we're simplifying, we keep that in mind, right? Okay, so these are the rules as we know them. Oh, and this number, by the way, can be written as 0 plus 2i, right? If this is the answer, we can write it in this form and just recognize we only have the imaginary part. We don't have a real number part. So this would be the answer to this little example I made up of how you simplify that and write it as a complex number. Okay, so this is what we already know. We've added and subtracted. We know that's not a big deal. You might have a big long string of numbers. You combine all the real numbers. You combine all the imaginaries. That's not hard at all. We treat the I just like any other variable, although it's not technically a variable. But let's practice the multiplying and dividing. Here is our first problema. I've been doing Duolingo Spanish. I studied Spanish for, 4 years when I was in high school, and then my daughters all studied Spanish when they were students, and we homeschooled, so I did a lot with them. I've been on vacation a couple times to Spanish-speaking countries, but I've never really, I just want to get better at Spanish. It's my life's mission, you guys. So anyway, I've been doing Duolingo, and now I'm just like quoting Spanish into all of my, I'm peppering Spanish words and phrases into my conversation. Okay. This is technically a division problem, right? We think of this as like a big, ugly fraction, but technically it's a division problem because it's 2 plus 3i divided by 4 minus 2i. All right. We notice they're both in a plus bi format. That's really cool. Now, what's supposed to happen in our brains when we see something like this is seeing an imaginary number in the denominator freaks us out. Just like seeing a radical in the bottom freaks us out, we don't want it. We want our denominators to be simple, clean, and pure, nice, real numbers. So, rational numbers is a better way to say it. So, if we've got this in the bottom, we want to get rid of it. How do we get rid of it? Same way that we got rid of our other problems in the denominator, we use the conjugate. And conjugates work exactly the same way as they do for radicals. So here's what our brains say. No complex numbers in denominator. Boo, hiss, we don't like them. And we will use conjugates, a fancy math word, to destroy them. Right? And again, a conjugate is where you take the same first term, the same last term, and then you change the sign in between them. The lead sign stays the same. The middle sign is what changes. If we do it to the bottom, we have to also do it to the top. As we remember from doing this with radicals, the bottom should turn out nice and clean. The top may not. The top might not. It may still have an I in it, but that's okay. We don't mind complex numbers in the numerator. It's the denominator that freaks us out. So let's multiply out the bottom. Oh, Grace is having a little dream. 4 plus 2i, 4 minus 2i. We do the dance, right? Boys in this row, girls in this row, they're all going to take turns dancing with each other. Teacher said, 4 times 4. Dancing is multiplying, P.S. 4 times 4 is 16. 4 times 2i is positive 8i. We just multiply the numbers. There's no trick to that. She's done. She sits down. Now it's this girl's turn. She multiplies this way. Again, there's nothing fancy. We just multiply the numbers. That becomes minus 8i. Oh, the conjugate's doing its magic right here. And then this is where it gets a little fancy. This becomes minus, right, plus and minus, 4i squared. But the I squared, we remembered, equals minus 1. So this becomes minus 1, and these two go together to make plus 4, and I'm circling it to show that's my final sign. Once you get the hang of these, you can do more of this work in your head, and you can put that number right over here because that's where we're going to want it to combine with the 16, right? So I'm bringing this number over here, and now we can add, and we'll get 20, and this cancels. So our new denominator is 20. Oh, that seems much better, doesn't it? All right, now we shall do the top. 2 plus 3i times that one. Okay, and again, these two are just stuck with each other. It's the bottom that tells us what we should be multiplying by, and then we just have to multiply the top by the same. There's no better reason than that. 4 times 2 is 8. 4 times 3i is 12i. She's done her turn. This is 4i, and then here we go. This is positive 6i squared. That turns into a minus 1. That turns this into a minus 6. See how I can do all that in my head? If you prefer to write it out as like plus 6i squared, and then change that into a -1, and then there it is there. That's perfectly fine. But I'm fine with you doing that calculation in your head. 2 plus 16i. All right, and I'm going to work down here. It's going to get a little squishy. Now we have 2 plus 16i over 20. I get excited. Those are all even numbers, so I can factor, let's see, a 2 out of the top. And that will be 1 plus 8i. And that's over 20. Now I can cancel. I'll have 10 left in the bottom. So our final answer is 1 plus 8i over 10. That might not make you feel better, but as an established mathematician, your heart sings because this is now a nice rational number, no complex boogeyman hanging out in our denominator. So that's the right answer. Cool, right? But we want to write it, oh, I remember one more thing I want to say about this. We don't want to write it as a simple fraction because that is not proper a plus bi format. They need to be separate. So what we want to do is write it as 1 over 10 plus, and then 8 over 10i, but we can cancel that. Here, let me do it one more time. Over here. We have 1 plus 8i over 10, and that equals 1 over 10 plus 8 over 10i. I'm okay with that being a floaty I. This can cancel. We can take 2 out of top and bottom, and we get 1 over 10 plus 4 over 5i. That is our final answer. So we split them apart, and we reduce as much as we can to do our final. Fancy and pretty, right? So when you get to this stage, see, I got too excited. When you get to this stage and get this answer, you're not done because they need to be split apart. That's what's super important, and it's something that you'll get more and more used to as we go. Let's do another one. Example 81.2, and this is the last problem in this lesson. 4 minus 2i over 2i minus 3. Okay, now as we look at this, horrors, there's an imaginary number in the bottom. And that's bad enough, but it's also, it's not in a plus bi order, right? That magical unicorn shape of a complex number. We can still work it this way and then make sure we're like this in the end. It's not necessary to rearrange this now. So that's what we're gonna do. If you look in the book, John fixes it. He makes it minus 3 plus 2i, just for fun, but he does say you don't have to change it. I'm gonna leave it like this and we'll multiply it and see how, it's fine. You can just fix it in the end. No, we're not, because I'm gonna tell you why. The conjugate has to be based on this in order to get the i's to cancel properly. So I'm going to retract everything I just said. I'm eating my words right now with a little sriracha. It's too hard to find the conjugate correctly if you've got the numbers in the wrong order. So that's why you want to put them in the right order, is because it'll make it much easier to calculate your conjugate properly. Here you would have to make your conjugate based on minus 2i. It's confusing. So fix it first so that you get the right conjugate. That is the conjugate of this. Front sign stays the same, middle sign changes. The I is in the last position. Make sense? Okay, so we flipped that around so it's in the proper setting, and then we find the conjugate. Now we're ready to multiply. Bottom. Minus 3 plus 2i minus 3 minus 2i. We multiply. Positive 9 minus 6i. Ooh, look at this one, plus 6i. And then here we go. This is minus 4i squared. So this gives me a minus 4, and this means plus 4. Those cancel, and I get 13 right there. Now let's do the top. 4 minus 2i times minus 3 minus 2i. Ready? We're multiplying, so this is minus 12 plus 6i, right? Minus 8i plus 4i squared. This turns into a minus 1, and then we get minus 4 right there. Minus 16 minus 2i. It'll go over this denominator of 13. I'm going to go to the next page. So I'll just write it right here. We want to split these, so it will be minus 16 over 13 minus 2i over 13. There's no way to reduce that, but we do want to write them as separate fractions. I put my I up here in the numerator. This time I put it floaty. Either one is fine. I wanted you to see both ways of doing it. It's absolutely fine both ways. I guess I kind of prefer this because it just stays so strong to this A plus BI format. But this is okay too. And as you can see, the way I calculated my numerator, top, that's where the I was living in this calculation, so it kind of makes sense to write it like this, but it's just as correct to write it this way. The most important thing is getting those two fractions into different sides so that I can see my real number and my imaginary number very clearly. Okay, that's the end of lesson 81. You now know how to multiply and divide complex numbers. Go brag to your friends. Okay, bye.